Friends, we know that while we see the water waves, we whenever we throw a stone in the water, we have observed that there is one wave which is at very high, and the other wave seems to be at the lower side. Okay, so two types of pattern you observe that one is called as uh, crust, and the other is called as the trough. Okay, so the crust which appears has the high energy waves coming towards the height of the water level, and the trough is downwards. But when we throw two stones, two waves propagate, and what was the if both waves high means crust met, so they reinforce each other, they enhance their height, and so the uh, level of the water rises, and where the one crust and one trough meets. Okay, so down here you can see the downward uh, of the if the both direct meeting waves direction is same, so there we found the constructive type interference, and whenever the opposite means one energy waves is at height and other is at lowest, so they cancelled out each other. So this type of node you can see, so one is at higher energy waves and one is at zero energy waves. Higher energy waves, so maxima, this is called as maxima, and the minimum is called as and the cancelling out waves produce minima, means there is no any intensity at that. Hello friends, my name is Pankaj Kumar Pandey. So I have brings here Young's double slit experiment. For modern theories of the light as a wave, there was two scientists who was struggling with each other for establishing their phenomena about the different nature of the light. So according to Newton has says that light act as a particle. What he has shows his by his photoelectric effect, and by the light speed in the mediums. There was another scientist of the same age, Huygens, who was just believed that the light have wave theories, wave fronts, and they travel like a wave. So light behaves like a wave. But Huygens has not. He has just given a theory, but it could not prove in the uh, experimentally. Later on, Young's who has done one experiment that is called as Young's double slit experiment. What he did, he has chosen a monochromatic light. Okay, and there is a slit one and slit two. So, he produces two slits on the screen, and there is another screens who observe the patterns of the both wave, both the same means waves coming from the two slits at a point P. Okay, so it there was some condition like light has to be coherent. Okay, what is the coherent source? Coherent means same frequency and constant phase difference. Okay, the light is not changing its phase, and also this has the same frequency. So when the source AC produce one means light, and it is entering at slit 1 and slit 2. So from slit 1 light travel at point P, and from S2 the light travel at point P. Okay, so because the slightly increased distance of slit 2 from the point P, there is a path difference of the light. Okay, so what would be that path difference? If we draw a perpendicular over the S2P line, okay, so we see that S2N has delta equals to d sine theta, means a difference. The delta is the difference of the distance of the light traveled to P from slit 1 to slit T2 is the called as the d sine theta. This is the path difference of the light. Okay. We know that the wave equation of in the free space is del square E uh, equals to 1 upon c square del square E upon day with respect to time chi square. Okay. So here is the notation. E is the electric field and c is the speed of light. So if we solve this equation, we will discuss in the later in the wave theory of the uh, particles, light and electrons. We will discuss about the wave theory, and so we will derive this equation. But currently, the solution of the this wave front is like E with respect to time equals to E naught cos k dot r minus omega t. Okay, where E naught is amplitude, K is wave factor, that is 2 pi upon lambda, omega is angular frequency of the light, and R is a position vector. Okay, T is the time. This describes light propagates on a oscillating electric field. Okay, this equation is important because we have to calculate their means impact while we calculating over the when the both waves meet at the point. Okay, so the when the both waves meet at point P, their resultant electric field will be 2 E naught cos nd sin theta upon lambda cos kr minus wt. This is the superposition of the two waves, and this final equation comes out. The final equation derivation is not in the syllabus, but yes, we will discuss later on in somewhere in some other videos. But this resultant equation will come out. Okay, so we know that I intensity always proportional to E square. So intensity of the light I theta would be the I max I naught I max or I naught cos square pi d sine theta upon lambda. This give alternating bright and dark fringes. We already knows that path difference delta equals to d sine theta. For cast, so for sine theta to be a maximum, what should be there? Okay, d sine theta must be equals to n into lambda. Okay, so where is the lambda is the wavelength of the light, and for destructive interference g sine theta must be equals to 2n plus 1 up into lambda upon 2. So here for cos theta's maximum value will be obtained at 0 pi 2 pi in similar manner. Okay, so adjusting these equations to get the desired maximum of the pi I theta or I naught I theta value, so cos square must be at maximum value. For destructive, d sine theta should be in terms of pi by 2, 3 pi by 2, 5 pi by 2, means at 90 degree of the angles cos theta becomes 0. So at that point minima will be observed. The minimum intensity will be observed. That is mathematically we can understand. Okay. So if we find that nth fringe, bright fringe is formed, so angular position of that nth fringe will be sine theta n equals to n lambda upon small d, which is the distance of the slit. As we know that if it's because the slit distance is very small in compared to the distance between the slits and the screen, so we know that in very small angle, at very small angle, sine theta can be converted into the tan theta. It is equivalent to tan theta, and tan theta is what that would be the x small x upon d. Okay, where x is the distance of the fringe from the central maximum on the screen. Okay, so we while we balance this equation, x n upon d equals to n lambda upon d, what we have calculated. So if you equating xd is nothing but xn, means at nth fringe, and this was formed due to sine theta was very small, so x upon d found, and also we know that sine theta n equals to n lambda upon small d. So we found this equation. Okay, so what we get that is this represent from this representation that here is light source, here is the two slits, these are the waves which is coming at, and these are the pattern of the maxima and minima because of interference of the light constructive. If there is constructive experiment, means if both waves are not cancelling out but enhancing each other, reinforcing each other, so maxima will be observed, while the waves where they are cancelling each other, then minima is observed. You can see that the more bright fringes are at the maxima. Okay, and if you want to find the position of the fringe, so you can say that at the nth bright fringe, x n equals to n L lambda d, capital D upon small d. This gives the location of nth bright fringe on the screen, and separation between successive fringe if you want to calculate. So we will take the fringes which is one fringe higher than the nth fringe. So beta will be the fringe distance. So we can calculate xn plus 1th fringe minus xnth fringe. Okay, substituting the value we and solving the equation, we get the fringe separation equals to lambda into capital D upon small d. So the fringe width depends upon lambda and the separation of the screen from the slits, and small d, which is the distance between the slits. Okay, so this is very important equations. Here is the very good interpretation from this experiment. Which must have to be noted down. The path difference formula d sin theta lead to the condition of maxima and minima. So what is ultimately affecting the path difference? What we have calculated earlier, because of the path traveled by the lights and their differences come. This is the leading the cause of the maxima and minima. And second was what approximation we have taken, that theta is very small, so we can take x upon d with respect to the sine theta, and sine theta's value we already calculated. So L lambda upon d, by equating these equations we get the and solving two adjacent fringe, we get the fringe width. So here is a basically linear manifestation of the angular separation directed by path, means angular representation, linear representation we get on the screen as angular position of the fringes. Okay, these are the schematic arrangement of the young Slit student for more clarity and for enhancing or presenting in different ways for clarity of the concept. So the light source is, what is the light source? Source is the coherent and monochromatic light, and it should have coherent means their frequency and wavelength are the same, and phase is also constant. Here is the waves coming from the two slits, and the maxima and minima pattern observed. Maxima is that when waves are reinforcing each other, means the position of the uh, crust is at higher, and the trough and crust while meeting they are causing minima. So the higher is the reinforcing, and the dark pattern is showing that there is cancelling out of the waves. This is another the systematic teaching board. You can just refer for your knowledge. So These was all about the Young's double slit experiment. This experiment was later on done by the De Broglie also by keeping electrons beams uh, and not light. So he has not used light but electrons. So he also later on in later chapters we will discuss about that. Thank you. Thank you very much for watching. Please, if you found some useful, then you must please like it. Thank you very much.